to solve exponential equations with the same base. And the property we're going to use here is if a to the x equals a to the y, so we have two equivalent powers with the same base, then we can conclude that x is equal to y. So we look, we have a power equal to a power, same base. We set the bases equal to each other, and then we solve for x. And then we can check 3 to the 12th is equal to 3 to the 12th. Same base, equal powers. We set the exponents equal to each other, and then we solve for the exponent. And we can check 100 to the 4th is equal to 100 to the 4th. Okay, here we do not have the same base, but we can rewrite 8 as base 2 exponent 3. So what's getting replaced here? The 8's being replaced with 2 cubed. And then we have equals 2 to the 2x minus 1. Now we're not ready yet to set things equal to each other because we have to take care of this using properties of exponents. So I have a power of a power. So now I have 2 to the 3 times 2x's, or 6x equals 2 to the 2x minus 1. I have now equivalent powers, a base, exponent, same base, so we set the exponents equal to each other and solve for x. And again, we can check 8 to the 1/2 should be equal to 2 to the negative 3/2. All right. These bases don't match, but we could write them in the same base. So we just kind of have to, if we don't remember, we can get our calculator. We want to try to make 64 match the smaller base of 4. We know 4 squared isn't right because that's 16, but 4 to the 4th, or 4 to the 3rd is the same as 64. And what is getting replaced here? The 64 is replaced with 4 to the 3rd. And then we're going to use our properties of exponents. And I'll have 4 to the 2x minus 5 equals 4 to the 9x. Now I have equal powers, same base, set the exponents equal to each other, and solve for x. And we can always check. This one here, we have 2 equal powers, but the bases are not the same. You can decide which way you want to go. I think what I would recommend is always working with a whole base. So I would want to rethink this 1 over 6 is really 6 to the negative 1. So this is where all those properties of exponents that we practiced last year and this year are coming in handy. So what I'm replacing here is the 1/6, and I'm rewriting that in an equivalent way as 6 to the negative 1. And then I have 6 to the 5x plus 2. Now I have the same base, or not yet, equal powers, but I want to use my properties of exponents first to get 6 to the 5x plus 2 is equal to 6, negative 11 plus x. Now we can set the exponents equal to each other and solve for x. Let's move that for a moment. And I'm not concerned that I'm getting a negative value for x because we know the domain of an exponential function is all real numbers. So we can have negatives, we can have fractions, we can have a zero, we can have positive numbers because we don't have any restriction in our domain for an exponential function. We have our 10 to the 3x minus 10 and 1 over 100. You could do this all at once, but I'm going to take it a step at a time. I'm first going to rewrite like I did in the previous example. 1 over 100 is 100 to the negative 1. So these are the equivalent forms. Then I'm going to rethink 100, and that's really 10 squared. And now I'm going to use some properties of exponents here. I have a power of a power of a power. So I'm going to multiply all those together. So I'd have 2 times a negative 1, or a negative 2 times a 6x, which would be a negative 12x. And a negative 2 times a negative 1 is a positive 2. So now I have 10 to the negative 12x plus 2 equals 10 to the 3x minus 10. We have equal powers, same equivalent bases. Now we set the exponents equal to each other and solve for x. Just going to move this. And x is, when we simplify this, 3 goes into 12 4 times, 3 goes into 15 5 times. All right, let's get this. Now I cannot write base 32 as a power of 8, but I can rethink both 8 and 32 in a smaller base. So I'm rethinking, just like we did in the first problem, 8 as 2 cubed, but that's to the x minus 1, and then 32 is 2 to the 5th, and that's to the 3x minus 2. We do our properties of exponents, and I have 2 to the 3x minus 3 equals 2 to the 15x minus 10, equal power, same base, set the exponents equal to each other, solve for x. I cannot write 27 as a power of 9, but I can use a smaller base for each of these. 27 is 3 cubed, and 9 is 3 squared. And now I'm going to use my properties of exponents, and I will have 3 to the 12x minus 3 equals 3 to the, I had here with a 3x. 2 times 3 is 6x, and 2 times 8 is 16. Now I can set the exponents equal to each other and solve for x. And if you don't know the division, you just grab your calculator and take 18 divided by 6, and you'll get 3. All right, again, we might want to do this 2 steps. So 25 to the 10x plus 8 equals 125 to the negative 1 to the 4 minus 2x. And now again, I can't write 125 as using base 25, so I'm going to change both bases. So 25 is 5 squared to the 10x plus 8. 125, if you don't remember, is 5 to the third. But this is also to the negative 1, and then to the 4 minus 2x. And now we use our properties of exponents to get 5 to the 20x plus 16 equals 5. This would be a negative 3 times a 4, which would be a negative 12. And I have a negative 3 times a negative 2, which is a positive 6x. And then now I can set the exponents equal to each other and solve for x. Okay, there's a couple more that we're going to try. Three to the 4th to the 3 minus x, and this equals 3 to the negative 1 to the 5x minus 6. And I'll have 3 to the 12 minus 3x equals 3 to the negative 5x plus 6. 12 minus 3x equals negative 5x plus 6. And we'll solve for x. All right, so we've got 4. I'm going to rewrite that as 2 squared to the x, 2 to the negative 1 to the x minus 3. We're going to use our properties of exponents to get 2 to the 2x equals 2 to the negative x plus 3. Now I can set the exponents equal to each other and solve for x. All right, and last one we have here, I'm going to rewrite this in base 10. So that's 10 cubed to the x minus 3 equals 10 squared to the 2x plus 4. We're going to use our properties of our exponents here. And we're going to have 10 to the 3x minus 9 equals 10 to the 4x plus 8, equal powers, identical bases. We set the exponents equal to each other and solve for x.